Cannabis is often spoken about as if it were one thing, one plant, one drug, one effect. But chemically, cannabis is not a single substance at all. It is a system, a network of molecules whose behavior depends on structure, context, and environment. A shift in a single double bond can change how a compound interacts with your brain. A difference of less than 1% can determine whether a plant is legal or destroyed. And a misunderstanding of laboratory chemistry has shaped public policy, medicine, and industry for decades. In this video, we are not talking about opinions. We are talking about chemistry. By the end, you will understand what THC actually is, how CBD really works, why Δ8 exists at all, and how modern cannabis regulation is built on analytical blind spots rather than biological reality. Cannabinoids as a system. Cannabis produces over 100 known cannabinoids, technically called phytocannabinoids. Each one is a small organic molecule derived from the same biochemical backbone, yet each behaves differently in the human body. These compounds interact with a biological network known as the endocannabinoid system, a regulatory system involved in mood, pain, appetite, memory, inflammation, and neurological balance. The body uses receptors, primarily CB1 and CB2, to respond to cannabinoid signals. Some cannabinoids bind directly, some modulate indirectly, some block or soften the effects of others. This is why cannabis cannot be reduced to strong or weak, good or bad. It is a multivariable system where chemistry determines experience. Two cannabinoids dominate public discussion: THC and CBD. Understanding them requires understanding structure. What THC actually is: THC stands for tetrahydrocannabinol. Specifically, when people say THC, they usually mean Δ9-THC. Δ9-THC is psychoactive because of how it binds to CB1 receptors in the brain. Its three-dimensional structure allows it to fit into the receptor in a way that alters perception, time awareness, memory, and emotional response. This binding is not accidental. It is dictated by molecular geometry. Δ9-THC is the most abundant psychoactive cannabinoid found naturally in cannabis. Because of its effects, it became the legal and cultural reference point for all cannabis regulation. But Δ9-THC is not the only THC. Delta isomers, small changes, big effects. Δ8-THC and Δ10-THC are structural isomers of Δ9-THC. They share the same molecular formula, but the position of a double bond in the carbon ring is different. That difference matters. Δ8-THC binds less strongly to CB1 receptors. Users often describe its effects as milder, smoother, and less anxiety-inducing than Δ9. Δ10-THC binds even less effectively and tends to produce more stimulating, less euphoric effects, though scientific data on Δ10 remains limited. What matters here is not marketing, it is binding affinity. This is not speculation, it is analytical chemistry. CBD, non-psychoactive by design CBD cannabidiol, is structurally similar to THC, but behaves very differently. CBD does not strongly activate CB1 receptors. In fact, it often reduces the psychoactive effects of THC when both are present. CBD acts more like a regulatory molecule than a stimulant. It modulates receptor signaling, enzyme activity, and neurotransmitter release. This is why CBD is widely used for anxiety, inflammation, seizure disorders, and neurological balance without producing intoxication. Yet one persistent myth remains, that CBD can turn into THC inside the human body. This belief originates from laboratory experiments conducted under high heat or strongly acidic conditions that do not exist in human physiology. Comprehensive toxicological reviews show that while CBD can degrade into psychoactive cannabinoids under artificial acidic environments, there is no credible evidence that this conversion occurs in vivo in humans. Your body is not a reflux column. It is a regulated biological system. Why the confusion exists. Much of the confusion surrounding cannabinoids comes from analytical artifacts. Gas chromatography, especially GCMS, uses high temperatures that can induce decarboxylation and isomerization. In some cases, CBD or Δ9-THC can rearrange into Δ8-THC inside the instrument itself. Forensic mass spectrometry studies have shown that certain derivatization agents can cause Δ9-THC to isomerize during analysis, leading to false positives and misidentification. Industry, law, and chemistry collide. Cannabis regulation is built on thresholds measured in fractions of a percent. Hemp plants testing above legal Δ9-THC limits are often destroyed, regardless of total cannabinoid profile, despite containing medically valuable compounds. This has created incentives for chemical conversion, synthetic pathways, and regulatory loopholes, rather than holistic plant science. Synthesis. Think in systems. Cannabis is not dangerous because it is complex. It is dangerous when complexity is ignored. Understanding cannabis requires thinking in systems, molecular structure, receptor biology, analytical chemistry, and regulatory frameworks together. If this video changed how you think about THC, CBD, or cannabis regulation, that means it worked. Science doesn't simplify reality, it reveals it. If you want to explore these systems deeper, join the discussion, read the research, and stay curious. Because cannabis isn't just a plant, it's chemistry in motion.